we're asked to find the absolute extrema of the function x to the 1/3, that is the cube root of x, on the interval -8 to 27. Well, we know we need to look at the endpoints and we need to look at the critical numbers. So I'm going to do a slightly different order in this video than I did in the previous video. I'm going to look for the critical numbers first and then do my evaluating once I have those critical numbers, if any. So let's start by considering f prime of x is equal to, in this case, 1/3 x to the -2/3, which we could write as 1/3x to the +2/3. Now, we're not going to get any critical numbers from this derivative being 0 because it can't be 0. The numerator is a 1, and the only way for a fraction to ever be 0 is if the top is 0. So, interestingly enough, no critical numbers from the derivative being 0. However, we definitely do get critical numbers, or at least a critical number, from when this derivative is undefined. The value 0 for x will make the derivative undefined, and if we look back to the original function, x is a valid number for x, a valued value for x in the domain of the function. So our critical number is going to be 0. So we're going to need to evaluate this function, the original function, at the endpoint, so at -8, at 27, and then at any critical values in between, which in this case we found 0. So if we plug in -8, we should get -2. If we plug in 0, we get 0, and if we plug 27 in, we get 3. So we can see that we have an absolute minimum at the point -8 and -2, and an absolute maximum at the point 27 and 3. Once again, I encourage you, now that we've done this work, to graph this and make sure you can find all three of these points. Make sure that we found the correct points for the absolute min and the absolute max. Looking at x to the 1/3. Graph it on the window -8 to 27 for your x min and your x max, and then once again you can use that zoom fit option to let the calculator choose good y min and y maxes so you can see the entire picture.